Okay, so this was the question from the quiz that we did last week, and it was a blended question, which is something we haven't done together before, but it follows all the same rules. The only difference with a blended question is that instead of looking at just the final product, instead of thinking about whether you're selling or maximizing profit, or thinking about costs of your final product, with a blended question, you have to consider the ingredients or the process to getting to a final product. And that process has its own costs and decisions to be considered in the question. So in this particular question, our final product was petrol and diesel. Shell creates petrol and diesel from a combination of gasoline, butane, and crude oil. And we've been given these percentages around if we're making 1 liter of petrol or 10 liters of petrol, doesn't matter. But whatever amount of petrol we make, at least 40% of that amount will include gasoline, and 10 to 30% of it will be butane. For diesel, we'll have at least 20% gasoline in each component of diesel, and 2 to 1 parts crude. So that means that if you put 20, let's say you put 20 liters of crude, then twice that will be butane. So 20 liters of crude will mean 40 liters of butane. 10 liters of crude will mean 20 liters of butane. And there's ways to interpret all of these constraints algebraically. We've also been given in the question the maximum supply of gasoline, butane, and crude in terms of how much we have available to put in our petrol and diesel, and this is how much we have available per month. And what we wanted to find was the expected maximum profit on selling the petrol and diesel after they've made that. In terms of the cost that is involved in making the petrol and diesel, we were given the costs for the ingredients. And we were told how much we sell the petrol and the diesel for at the end of the day. So if you think about profit, unlike every other question that we've seen up until now, every time we wanted to maximize profit, we would have profit amounts in the question for our decision variables. Every time we wanted to minimize costs, we would have cost amounts for our decision variables. In this case, we wanted to maximize profit, but we did not have profit amounts, okay, on our decision variables. And all we had was how much it costs to make something and the revenue or the selling price for the final product. So if you think about how we make, how we formulate profit, so the formula for profit, if I was to say something like, I've made a cake and it cost me 300 rupees to make this cake, and I'm going to sell it for 700 rupees. How much profit have I made? Anybody? Hello, are you all there?
400 rupees.
How did you get that, Papa?
The selling price minus the cost, or the revenue minus the cost.
Exactly. So the amount I sold it for minus the cost incurred when I was making the thing. Okay, so that's what we have to do here, except your costs will be on your petrol and diesel, and I mean your revenue will be on your petrol and diesel, your final product that you make, but your costs will be relating to the ingredients. Okay, and in terms of how you set up your decision variables, it's easy to assign that to what those variables are. Let's calculate the optimal solution. So as mentioned before, our objective is to maximize profit when we're selling our petrol and diesel. In the walkthrough, I've explained that the first step of any LP question is to define the objective. I think what I've noticed, whenever we have office hours and on the few questions I've marked for people, is that a lot of people will read the question and think they already know what needs to happen in terms of the constraints, and they'll skip steps. And then they'll start working out constraints. They'll start working out what 40% of 2,000 liters is, so 40% of 2,000 liters, and that's the entirely wrong approach to an LP question. If you decide that you already know what's going on, you are going to miss a lot of the details and make such a huge mess of this question that you won't even know where to start. Once you're confused, you are so catastrophically confused. So I advise that you avoid that, okay? These 4 steps are so important in terms of framing your mind around what those constraints will be. If you skip the steps before, and if you don't go through this in order, you are going to suffer for it. Okay, and as you know already, this objective step is always either maximizing profit, maximizing revenue, or minimizing costs. That's what we've seen so far in terms of business-related questions. Now, our decision, because what we're making at the end of the day is petrol and diesel, our decision is to how much petrol and diesel are we going to make. But not just that, we've also got to decide how much of our ingredients to put into the petrol and diesel in order to maximize these profits. Because we haven't been given exact amounts for the ingredients, we've just been told this might be at least 40. That means I can have 40% gasoline, I can have 50% gasoline, I can have 60% gasoline, I can have any percentage, but there's a particular percentage that will maximize my profits. And I want to find what that percentage is, or what that amount is, the amount of gasoline. So your decision will actually have to clearly state that not only are you trying to decide how much petrol and diesel to make, but you're trying to decide how much gasoline, butane, and crude oil to blend together to make petrol and diesel in a way that maximizes your profits. Everybody understand that up to now? Yes or
Yes.
no? Cool. Everybody else who's here? Okay, I'm going to ask one of you to just please type in the chat in the Hangouts group that we're going through this question, so that if anybody is still battling with it, they show up to office hours. Just mention that we're going through the petrol diesel question if anybody wants to join class.
Is this for cohort 1 only?
Pardon?
Is this for cohort 1 only?
Yeah, I'll do it again for cohort 2, but it depends on what the office hours requirements for cohort 2 are.
Okay.
Maybe, I guess it can be open to anybody.
Okay.
Okay. Okay, so we've got our objective, we've got our decision. Our decision variables are based on what the decision is. So if we're thinking about how much of our ingredients make up each final product, then it means that our decision variables need to have some combination of the ingredient and the final product. How much gasoline needs to go into petrol? How much gasoline needs to go into diesel? The same for butane. How much butane needs to go into petrol? How much butane needs to go into diesel? How much crude oil needs to go into petrol? How much crude oil needs to go into diesel? Everybody understand how we constructed those?
Yeah. understand.
Okay. So the key thing to notice here is because it's a blended question, because our decision is not just how much petrol are we making, how much diesel are we making, it's actually how much of each ingredient goes into each product. Because we're blending something into something else, your decision variables are a combination of your ingredient and your final product. You couldn't have had your decision variables as just petrol, just diesel, because if just P, just D doesn't tell me how much of each ingredient went into that. Telling me just gasoline, just butane, just crude oil doesn't tell me how much gasoline went into petrol, how much gasoline went into diesel. Those are two different things I'm making decisions about. So those are two different variables I need to have algebraic notation for. Okay. The same is applied to our transport questions, our investment questions, where if there's a combination of two things, if there's an intersection in a table for two things, then you need to have two letters in your abbreviations for the decision variables. Okay. Next step is the objective function. And remember, your objective function takes into account all of your decision variables, and it's a function that's based on what you're trying to do. If what I'm trying to do is maximize the profit, then my objective function is a max function, and it has to be profit that I'm maximizing. So all of my amounts or my coefficients must be profit. If I was minimizing cost, all of my coefficients for my decision variables would be cost. Okay, if I was talking about maximizing revenue, all of my coefficients for my decision variables would be revenue. In this case, all of these should have been profit, but we didn't have profit in the question. Okay, so because we didn't have profit in the question, I'm actually going to just change this to make this clear. Because we didn't have profit in the question for all of our various decision variables, we didn't have the profit made on petrol, we didn't have the profit made on diesel. What we did have was the selling price of our final product and the cost for our individual product. If we know that the formula to calculate profit, as we said just now, is your revenue minus your cost, then we can use that. Okay, we can say, what is the revenue in terms of our decision variables? What is the cost in terms of our decision variables? Take all of our revenue minus all of our cost, and that gives us the same as if we had had profit amounts. Our revenue was in terms of petrol and diesel. Our costs, so what I mean by that is in the question, we got the selling price for petrol, we got the selling price for diesel. We didn't get the revenue amounts for the ingredients. We just got the revenue amounts for the final products. Our costs were the cost on the ingredients. We can't possibly have costs on the final product because we haven't made it yet. So our cost was relating to gasoline, to butane, to crude oil. Okay, and so when we set up our objective function, remember, is a combination of all of your variables. So I've actually got to have a combination of all of my variables for the revenue part. I've got to have a combination of all of my variables for the cost part. But when I apply the numbers that I have, okay, I know that the selling price for petrol is $8. The selling price for diesel, petrol is $9, diesel is $8. So when I combine my variables, anything that has petrol in it will cost $9. Will be sold for $9. So anywhere you see a P, I've got $9. Anywhere you see a D, I've got $8. If you like, I could have written that out as my petrol is made up of gasoline. It's made up of butane and crude oil, and all of that is going to be sold at $9, right? That would have been my starting point. But when I open up that equation, I'm going to have PG. If I multiply that P into everything, PG plus PB plus PC. And then if I multiply the 9 into everything, 9 in front of every single one of them. Do you all follow? Any questions so far?
Yes.
Okay. And the same for my diesel. My diesel is made up of my gasoline, butane, crude oil. And when I open out the equation, I now put my 8 in front of every one of those. Okay. Now, I'm just going to neaten this up. This is all in the walkthrough, so I don't want to leave it here. The second part of my equation is the cost part, and we do it similarly to how we did our revenue part. So for the cost part, I had cost for gasoline, butane, and crude oil. So in this case, what I do is anytime I see a gasoline, anytime I see anything with a G in my decision variables, the cost for that will be $3. So everything with a G, if you think about it, gasoline goes into my petrol, and it also goes into my diesel. Okay, if I open that out, I have GP and I have GD, right? So I would just have GP plus GD. That entire equation would have to be multiplied by the cost of gasoline, which is $3. And here's my $3 for petrol, gasoline, for the GP. Anywhere I have G, another one is GD. So there you have again 3DG because I have gasoline. And I did that for everything else. So anywhere I had butane, anywhere with a B, I had $4. 4PB, 4DB. Anywhere with crude oil, I had $2. 2PC, 2DC. And that's my formula to get my profit. It's a little bit lengthy, but remember, Solver does this for you. At the end of the day, you're going to ask Solver to give you all of these decision variables, and it will just work this out. Now, just going to keep getting in the way. Oh, oops. Sorry. Just give me a second. I'm going to pause the recording here. Okay, if everybody's happy, we can carry on to the next part. Over here, all I did was simplify that equation. So if you open it up, because I am mentioning all of my variables twice, you can actually solve that. So 9PG minus 3PG gives you 6PG. 9PB minus 4PB, remember the minus and the plus here makes a minus. So 9PB minus 4PB gives me 5PB. And you do that for the rest of your equation so that you have it in its simplest form for when you put it into Solver. Okay. And again, this is the optimal solution that is actually maximized profit. Now, this is the part that Papa mentioned that he wasn't really sure what was happening, and I'll go through this slowly. We are supposed to end this at 12. I hope we have enough time. Okay, so for our constraints are around the amount of ingredients that we have to put into our total. We also have a certain amount of capacity in terms of the supply of the ingredients. So it's not just the percentages going into each final product, it's also the total amount of liters we have available of these ingredients. We cannot use more than we have. But we must also make sure that we put in the necessary proportions to make up the petrol. Okay, now each of these are represented in the constraints individually. Okay, so I think I'm hearing somebody in the background. Please just make sure you're all muted. And just unmute yourselves to stop me. So at least 40% gasoline makes up, must go into my petrol. What that means, okay, remember that my petrol is made up of my gasoline, my butane, my crude oil, okay? That's what's in my petrol. The question doesn't give you a constraint around how much crude oil must go into petrol, but it does say that petrol and diesel are combined, include a combination of the ingredients gasoline, butane, and crude oil. So just because they didn't give you a percentage for the crude oil doesn't mean that this stops being true. Both petrol and diesel have a combination of all three ingredients. So when I am formulating my equation for petrol, what we did, remember, was actually take this petrol and work it into each ingredient. So we have GP, we have BP, we have CP. That makes up all of my petrol. My petrol is made up of all three ingredients. If I say that at least 40% of petrol is gasoline, what that means is 40% of this whole thing will be gasoline. Okay, the gasoline and petrol will essentially be 40% of the whole petrol equation. Does that make sense?
Yeah, that makes sense.
Okay. And what that also means is I can open this out and solve it. So my gasoline and my petrol will be equal to, you're now putting your 0.4 in front of everything, GP plus 0.4 BP plus 0.4 CP. Everybody follow this? I just opened out that bracket and put my 0.4 in front of every component of my equation. And I can solve it even further and say, oops, sorry, my sign is wrong. Gasoline is at least 40%, so it can be more than that. Same here, it's at least 40%, it can be more than the 40%. Now, I can take my GPs to one side so that I have one GP. This becomes a negative. So one GP minus the 0.4 GP. Okay, all I've done is actually put the coefficient in front of that GP. If there is no coefficient, it means it's a 1. Okay, so 1 minus 0.4 leaves me with 0.6 GP. And everything else is fine on the other side. Now, at this stage, I've got one coefficient. Who is unmuted here?
Wait, Mutsa, excuse me.
Yeah, sure.
So I'm not sure about so did you just add all of those GP up to get the second part, the 1 minus 0.4?
No, so
Like,
all
how
I'm
did you
doing
get that
here
value?
is I'm trying to get my GPs on one side of the equation so I can solve for my GPs. So
Oh,
I've got
okay. Okay.
one GP on this side, so there's my one GP. If I bring the 0.4 to the other side, it becomes a negative 0.4 GP, and then I've left everything else on the other side.
Oh, okay.
And then if I say 1 minus 0.4, I'm left with 0.6.
Okay.
Okay. And once I've done that, remember that we always want to have a left-hand side and a right-hand side, and the right-hand side needs to be a number. So we need to tell solver to solve our left-hand side to meet a certain right-hand side. Because I don't have a number here, if I move everything to one side, I actually end up with a 0 on the other side, which is what happened here. So all that happened is I moved the rest to the same side as my GP. Okay, I could have done it the other way. I could have said, take this across, except I'd have a 0 on my left and my numbers on my right. So I'd rather move everything to my left, all of my decision variables. When I move 0.4 BP, it becomes a negative 0.4 BP. When I move 0.4 CP, it becomes a negative 0.4 CP. It doesn't matter which way around, CP or PC, it's the same thing. And then I'm left with 0 on the other side. So here's my 0 on my right-hand side. Everybody understand that? Any questions?
Nope.
Okay.
Mutsa, so even though you weren't given the amount of crude oil, you just assumed it was all the same?
I'm not talking about crude oil here. I'm talking about gasoline.
No, for the amount, like for CP, you put 0.4.
Yeah, so that's about where I started. If I look at what they said in the equation, in the question here, they say at least 40% of whatever petrol is, right? Whatever amount I put in petrol, at least 40% of the whole combination of petrol must be gasoline. My petrol combination is made up of gasoline, butane, and crude oil.
Oh, okay.
Okay, so what I started by doing here was saying, okay, I know that my petrol combination, I know that to get petrol, I must have a combination of gasoline, butane, crude oil. Before I say 40% of that, I can open this out to look like my decision variables. If I'm talking about the gasoline and butane and crude oil in petrol, then I know that I'm talking about GP, BP, CP, not D, because this is all petrol. And what I'm trying to do is work out how much of all of that petrol is gasoline. And according to the question, the gasoline part of this whole petrol cake, okay, of this whole petrol equation that I have is 40%. So 40% of the whole equation will be gasoline. All I was doing now here is solving this equation to get to a left-hand side and right-hand side that leaves me with a number on the other side, on the right. So I opened this out. My 0.4 now goes next to everything. My crude oil is in here because I'm talking about this entire petrol combination. I have to refer to the gasoline as 40% of the entire combination.
Okay.
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 Any other questions? Okay. Hope none of you are speaking on mute. Okay. So we do the same thing with the rest of our constraints. You just have to remember that anytime you get a percentage, it's a percentage of a whole. So you always have to start your equation by representing the whole, putting in whatever your percentage is, in this case, the 0.4, and making sure your sign is the right way. So are we saying at least? Are we saying at most? And then you solve your equation, okay? And you keep solving until you can have all of your letters on one side. At this stage, I was able to now move all of my letters to one side and leave 0 on the other side. That's what will always happen with your percentage ones. You will always end up with a 0 on your right-hand side because we don't necessarily have a capacity that it must meet. We just know that the whole of this whole, a percentage goes to something, another percentage goes to something else. So I'll just tell you where we started for the rest of these equations. So with butane, I know that it can't be less than 10%, it can't be more than 30%. And here it was even nice of me to split that. I could have said something like, I could have represented it in this way, that we can't have less than 10% for a butane, and we can't have more than 30%. You would have to know, if your format is double-sided like this, that you have to do each side individually. So what I did in the question was I did the one side, at least 10% is butane, and then I took the other side separately, that butane can't be more than 30%, so no more than 30% butane. And you have to do each of those individually in your constraints. And you do them exactly as we did before. So if I say, we've done an at least one, so I'm going to do the other one, the at most one. So no more than 30% butane. Okay, with that equation, this is for my third constraint, sorry. I'm just going to put it in the right place. This is still the amount of butane in petrol. I still start at the same place where I'm looking at how much, how my full combination of petrol is PG plus PB plus PC, and I'm interested in the percentage of that that goes to butane. And here we're saying it's no more than 30%. So essentially what that means is the PB part of this, okay? It cannot be more than 30%. So it can be less than, but it can't be more. So it'll be less than or equal to 30% of my petrol. And my petrol is made up of that full thing. So PG plus PB plus PC. Everything is in the petrol. 30% of that will be my butane. And then from here, you do exactly what we did before. You open out your bracket, you put your PBs together because you'll have two of them now. Okay, so when you've opened out your bracket, put your PBs together. Let's just go through that. Less than or equal to 0.3 PG plus 0.3 PB plus 0.3 PC. That's just opening up my bracket. Because I've got 2 PBs, I'm going to take this one to the other side. So I'll have 1 PB minus 0.3 PB, which leaves me with 0.7 PB. And I'll be left with the others on the other side. Papa, which side do I want the 0 on?
The right.
So what am I going to move here?
The 0.3 is to the left.
Okay, so I move everything to the left. If I take the 0.3 PG, this becomes a negative 0.3 PG. The PC also becomes a negative. And I'm left with a 0 on the other side, and I'm happy with my right-hand side, left-hand side, so that when I'm setting up my constraints, I've got coefficients for my decision variables, and I've got a right-hand side. So it's easy to set up the table. Amy, how did I get this 0.7 PB?
You minus the 1 from 0.3.
Exactly. So I put my PBs on one side, which meant that I had 1 PB, this guy, minus the other one from the other side, which left me with 0.7 PB. And this equation is exactly what I have for the 30% side of my butane. So there's that constraint. The 10% one, you should be able to do. The gasoline and diesel, similar concept. Okay, so here you've got at least 20% gasoline in diesel. We've seen an at least example, so you should be able to do that. The only one we haven't done together is 2 parts butane to 1 part crude oil. That part is not as complicated as it sounds. Okay? If you were told, so I'm going to ask you guys, if you were told 1 part flour to 2 parts sugar, right? If that's what the ingredients say. 1 part flour to 2 parts sugar. When you're doing your measuring, Annie, if we say that for the 1 part flour, if you decide, okay, I'm going to put 100 grams of flour, how much sugar would you put?
Sorry, you said one part flour, 2 parts sugar, right?
Mm-hmm.
So if you put 100 grams of flour, shouldn't you put 200 grams of sugar?
Perfect. What if I said 1 part water to, no, let's say 1 part lime, vodka. 1 part vodka to 2 parts lime. I'm going to now ask, this doesn't mean you're an alcoholic, Theka. If I say we're putting 1 part vodka to 2 parts lime, if I put 1 shot of vodka, how much lime am I putting?
I think we'll be putting twice of lime as much as vodka. Like if it's 1 shot vodka, will be 2 shot of limes. I mean.
Okay, so your intuition is correct. I did circles around myself and confused all of you, but your intuition is absolutely on point. When I'm baking, if I say 1 part flour to 2 parts vodka, it means if I put 100 grams of flour, I've got to put twice that of sugar. Same with if I'm mixing my drinks. 1 part vodka to 2 parts lime, it means the vodka will be half of whatever I put, however much the lime is. So 1 shot of vodka to 2 shots of lime. The same applies to if I'm now talking about the amount of butane and crude oil. In the question, it says 2 parts butane to 1 part crude oil. So if you like, I can just switch one of these to 2 parts butane to 1 part crude oil. Okay, so if I had similarly, let's say this was 10 liters, then this would be twice that, 20 liters. And my whole, remember this is to make up a whole, my whole would be made up of one of these things. I've done it again. No, this is correct. Okay, these two need to essentially make one drink, right? So crude plus butane need to make one drink. Or if you like, 1 shot vodka plus 2 shots lime need to make one drink. So if I take one to the other side, then crude must be equal to the negative amount of butane. If I have this as, if I bring, no, I'm still making a mess of it.
Yeah, I have a question. Isn't this like supposed to be like crude, crude plus 2, like crude oil plus 2 of butane equals to 1? If I'm not wrong,
You're on the right
like
track, but I think it's the other way around. So 20 liters is equal to 2 of these 10-liter things.
Hmm.
Do you agree? For these two to be equal, for my 20 to be equal to my crude, I'd actually have to put, because of the definition, 1 part to 2 parts, then I've got, remember, as we were saying here, if you put 100 grams, you put twice that for your 2 parts thing. But if you decide that you want to have an equal amount of both, then I'd have to multiply this part by 2, which is why you've got 2C here.
Mm-hmm.
That's spot on, Thika. Thanks for that. Do I need to explain that again?
Can you
Should be
just
okay.
explain that quickly? Can you just explain that quickly again?
Okay. So what we were trying to do was, remember, this is 1 part crude to 2 parts butane.
Yeah.
Okay. Now,
Yeah.
if I wanted to put this in an algebraic equation so that I have a left-hand side and a right-hand side, remember that the whole point is to equate your two things, right? But these two components, these two measures are not equal. These two measures are not equal. These two shot glasses are not equal. These 2 liter amounts are not equal. If I did want to make them equal, I would have to take this bottom row, this top row, and multiply that by 2 to be equal to the amount of butane that is in there. If I wanted them equal.
Okay. Okay.
Okay, so if I wanted them
Yeah.
equal, then this part would have to be multiplied by 2.
And so the 2, so the C is multiplied by 2.
That's why you've got the 2C. And remember, I'm trying to
Okay.
make them equal so that at the end of the day, when I subtract them from each other, I have 0 on the right-hand side.
Okay.
Okay, I could have as easily halved this. I could have said let's half this row. And that would mean
Yeah.
I have 1/2 B minus
Minus
C
C.
is equal to 0. But then I've got a half. It's not as pretty as a 2, but it's the same thing.
Yeah.
Okay, and remember
Yeah,
that
thank
this
you.
is specific to diesel. Okay, so this isn't actually just B. We're talking about BD, we're talking about CD. Okay, this is not true to petrol, it's only true to diesel. We're not really interested in how much gasoline goes into this. This is a ratio between just crude oil and butane. So when you put this in your constraints, I'm just going to take all of this out. When you put this in your constraints, remember that this is for diesel. This is for diesel. So that in your constraints, you're putting it under the right heading. So you'll notice when I do the butane crude oil ratio, it only came under diesel. Okay, and setting up your constraints is pretty easy. It's just taking the coefficients and putting it under the right heading, the way we normally set up our constraints, and having your right-hand side at the end, your left-hand side, your sign. The only part I hadn't covered was how much capacity we have for our gasoline, how much capacity we have for butane, how much capacity we have for crude oil, which was given in the question. And in terms of the algebraic equation, if we're talking about gasoline, there's gasoline in petrol and gasoline in diesel. The total of the two cannot exceed how much we have available. So it will be less than or equal to the 2,000 liters we have available. Does that make sense?
Okay.
Okay, and we do that for all three of our ingredients. And for the recording, I'll actually cut out the part where we're doing circles, just so you can listen to it in sequence and you don't get as confused as we did just now. When you now then set up these constraints for solver, remember that you are each decision variable, you want solver to give you back all 6 of them. All 6 of these have a revenue, all 6 of these have a cost. So this time your sum product formula is actually revenue minus cost, where you take each revenue number it highlighted all 3. Okay, purple and orange are my revenue. Purple and orange. So my revenue times each decision variable minus the cost bit, and the cost is the blue square. So blue square, the cost times the decision variable. And I could have done this using my final objective function because I had final profit numbers here. So I could have actually just set up a profit line instead of revenue and cost. And in my profit line, I would have put these coefficients so that I'm just doing one line times my decision variables as we normally do. But I did this to show you that you don't actually have to always have just the 2 lines. You can have this be an entire formula. Does that make sense?
Yeah.
Any questions before we look at the constraints part?
Is all of the decision variable, is it just 0? Or is it all just 0? Yeah.
Because it hasn't been solved yet. I haven't run it through solver.
Oh.
My solver isn't working. I should actually try and sort that out, and then I'll update the solution for you here. But no,
how do you get the division variable? Do you times, is there any
Pardon?
Like, what's the equation for the division variables? I mean, like,
There is no equation for your decision variables. Remember, solver gives you these decision variables based on your constraints. So behind your decision variables, there's nothing. Normally, when we set this up, I tell you, give these dummy numbers, just so you can see how this would be solved. But you take out your dummy numbers at the end of the day. Solver doesn't need formulas for these. It only needs a formula for your final optimal solution. That's the function. You also only need formulas for your left-hand side part. And what solver will do is it will look at these formulas that are based on your constraints and what you're trying to aim for, and then it will tell you what these need to be. You don't need to put formulas for that. You don't necessarily have a formula for how we calculate PG. You just have constraints that your different decision variables must meet, but none of them are exact formulas for getting the decision variables. So you will never have a formula for this part.
oh, okay.
Okay, so
What's that?
yes.
What's the sum products for the left hand side?
So that's the next part we're going into now. If there are no other questions about this setup for the solution, the next part is getting your constraints set up. Okay, and that is just taking your entire list of constraints. I forgot here non-negativity and integers. Let's think about those. Is it possible to have a negative number of liters? That's not a trick question.
Yeah, we know. No, it's not possible.
It's not possible. You can't have minus 3 liters or something. You can only have 0 and above that, but you can't have a negative number. So you do need to have non-negativity. Integers, do these need to be whole numbers, the numbers of liters? You can have 2.56 liters, right? So we don't actually need the integer constraint in this question. Integers is only if your solutions have to be whole numbers. In this case, they don't. When you set up your constraints, you take each equation and you set it up under your different headings for your decision variables. So we've got our decision variable headings across the top. Anytime I see for this first constraint, I should have 0.6, negative 0.4, negative 0.4. This is just for the petrol. So this is my 0.6, negative 0.4, and negative 0.4. Nothing under diesel for this constraint. Okay, so the diesel side of this will have nothing. And for the left-hand side calculation, remember your left-hand side is each of your coefficients times their decision variables. So you'll see that I've just multiplied the whole row times the decision variables. I'm not splitting it to petrol and diesel because I've already accounted for diesel not existing by putting zeros. So 0 times anything is 0. It won't give me anything for diesel. It will just work this out for the petrol side. And because I've put an absolute value on my decision variables, if I just copy that formula down, it will only change the purple row. So it will take the next row for the purple, the next row for the purple, the next row for the purple, every time it wants to work out the left-hand side. So you'll see that here's my left-hand side for not that one. For my third constraint, my purple moved down, but my decision variable stayed the same. The orange one with the $sign for absolute stayed the same. Only the purple line is moving when I copy my formula. And that is true for every combination of these first 4 constraints. Okay. So up until here, we were using that same formula. When we get to the butane and the crude oil one, I've only referred to those two. I could have kept the formula, it would have still done it. It was just for the sake of showing you that here I'm only dealing with the diesel. If you use the formula, because the rest of them are 0, if you use the formula that I use for the other constraints, it will still work. So you don't have to do it the way I did here. It's the same thing. It's taking the product of this times that plus coefficient of crude times decision variable for crude. It's a sum product formula just opened out. The only difference here is because I have B minus 2C, that negative stops the sum product aspect of it. So remember, a sum product is specifically when you are adding your products. So if I'm saying this times that plus, this times that plus, this times that, in this case, because I'm not saying plus, I'm saying B minus 2C, I opened it out. So the B part minus 2 times C. Everybody follow that?
Kind of.
Okay. Do you want me to explain it one more time?
Yes, please.
Yes, please.
Okay. For this equation, for this constraint, okay, I can't use a sum product formula for this constraint because a sum product formula only works when you are adding, the sums of everything. Okay, so the products of everything. So here, because I put the negative next to the actual number here, the minus 0.4, I can still say I'm adding, because when I add a minus, it subtracts. It knows that those are the BODMAS rules. Okay, so I can say a sum product of this times that plus this times that plus this times that, even though in my constraints these are actually being minused, because I've put the negative sign here, I can use the sum product formula and it will work fine. I could have done a similar thing with my B minus 2C. Okay, if I had said this is negative 2, B minus 2C, so that it represents the coefficients exactly as they are in the constraint setup, then I could have used the sum product formula, because when it sees a negative here, it knows what to do. But because I didn't put a negative here, because I just had 1 and 2, I had to use the full formula as you normally would. So I had to open it out to say, okay, take your constraint coefficient times the butane decision variable minus the 2C. I've told it explicitly to minus this way. If I hadn't done it this way, if I had put the negative in my coefficient, I wouldn't have to work it out like this. I could have used the sum product formula. Does that make sense? You can use either or, both are correct. You just have to be careful about the notation you use in your table so that you remember that if ever, okay, I'll just tell you a simple rule. If you want to always use some product, then you need to make sure that you put your negatives in your coefficients. So the way it's represented here as minus 2, I would have had to put this as a minus 2 in order to keep using the sum product formula. I did it the other way for those who don't do it this way, just so you remember that the minute you are not putting in your negatives in here, the sum product formula doesn't pick up that this was a negative. So you actually have to do it the long way around. If I had more numbers here, this formula would be much longer. It's just that I only have it for BD and DC, so I don't have to do it for everything, just for where I have coefficients. Does that make sense?
Yeah.
Okay. It's just a learning point. Okay. And then the rest of it still follows my sum product formula. So I've got my right hand side as the capacities. And on the left hand side, I've got my sum products for whatever the coefficients are that have shown up in here. So here, because I've got just PG, just DG, the coefficient of those, remember when we were working out, when we were solving these formulas, I told you that if there is no coefficient, it means the coefficient is 1, not that it doesn't exist. So where I have PG, I've got a 1. Where I've got DG, I've got a 1. So you'll see here, I've got a 1 under PG and a 1 under DG. Those are the coefficients this time. And that's my formula, a sum product formula. There was no negatives here. I didn't need to worry about that. No negatives in here. And then when you do it for solver, oh, I did do it. When you do it for solver, you have to remember to put in the non-negativity constraint. So when you're done with all of these, don't forget non-negativity. Josh, you asked me earlier about the actual solution. It is here at the bottom. So I've actually got liters for all of my ingredients for both of my products. So you'll see that I did have crude oil and petrol. I did have all three in diesel. And my optimal profit, my maximized profit, is that amount of money. So when you say your conclusion, this is your optimal profit to be made from blending 1172, 293, and 1462 liters of gasoline, butane, and crude oil into petrol, and blending 827, 2206, 1103 liters of gasoline, butane, and crude oil into diesel. And that's just the first part of your conclusion. Does anybody want to try the second part? It's written here, but you'll be able to read it for yourselves. I just want to know if any of you have mastered what we do when we're interpreting. Anyone?
Did you use solver or open solver?
This is open solver.
Okay.
This is a long time ago. But I uninstalled my open solver and I haven't been able to install it again. I'll let you know if I'm lucky one day so that the rest of you who are struggling with that can do it also when it's up and running.
Yeah.
Yeah.
But can you actually do it with solver?
It's supposed to be possible, but solver doesn't always handle the complex ones well. So you can try.
Okay.
Should be able to do it, but it doesn't always do it. And it doesn't give you a reason why. So you also can't tell if you've done something wrong or if it's just solver being solver. In practice,
Okay.
in business, there are other tools other than solver and open solver to run linear programming things. There's actual accounting tools. So you won't have to worry about this unless your business doesn't have, your company doesn't have a license for a better tool. Does anyone want to try the interpretation? Nobody? Have any of you been watching those videos? I'm waiting. I'd like you to try, then I can help you when you try. Doesn't matter if you don't get it right.
Okay, let me just give you the shot.
Okay?
So, like in terms of interpreting, we can deduce like we can deduce from the result we have that in order to make a profit, the this like because if I'm not wrong, the value 38,244 is actually the profit they're going to make after they've sold a certain amount of crude oil and I mean all the elements of that combination.
Mm.
Yeah, so maybe so probably the in order to have that like that profit, that is how much they should be able to sell.
Now, considering that they make petrol and diesel, can you tell me from these decision variables how much petrol is being made? How would you know what the total amount of petrol is and what the total amount of diesel is?
I think I'll add the amount of petrol for gasoline for petrol yeah, from gasoline, and that's from diesel maybe.
Exactly. So remember that we have ingredients going into petrol and diesel. And when we talk about what we're selling, we're actually selling petrol or diesel. So when you talk about this being the maximum profit, you have to say this is the maximum profit when we blend these amounts to make petrol, these amounts to make diesel. But in terms of what's actually being sold to make this profit, we are selling 2,931 liters of petrol, and we're selling 4,137 liters of diesel, which is maybe almost twice as much in order to make a maximum profit.
Okay.
Okay.
So it will probably be more profitable to sell diesel.
Pardon?
So it will probably be more profitable to sell diesel.
Not necessarily. It's just to achieve the maximum profit. Yes, we are selling more diesel than profit, than petrol. But obviously, what your client is going to say, there's no way I can just like, it's not like I can bring the customers and say, oh, all the diesel customers come here and only take half that same number for petrol in order to achieve maximum profit. You take what you get in terms of who comes into your service garage. Okay. But you would just be telling your client that, you know, when you're telling your workers to service people, if you see a diesel car, go service that guy first. That's where you're making most of your money. Okay. But beyond that, you also have to look at a big part of the interpretation is not only just interpreting in realistic terms. So here in realistic terms, what I mean is we're selling petrol and diesel. That's what your client wants to know, how much to blend into the two, but also at the end of the day, how much petrol am I selling? How much diesel am I selling? So you need to say that in numbers that are relatable to him. You need to add all of your diesel components, add all of your petrol components. You also need to tell him whether his left-hand side has met his right-hand side. Have we reached our capacities? So if we look at the ones where we are comparing against zero, that one was good, that one was good. The third one, we wanted to be less than or equal to zero. So it's fine. We can go as far less as we want. It doesn't matter. We want it to be more than or equal zero here. It's completely coincidental that these numbers actually were 0 on the right hand side. If it had gone above 0 and gone to 1,300, it doesn't matter as long as it is above 0, okay? Because the sign just says be greater than or equal to. We only care about it being exact when the sign says be equal to. We want to make sure that solver has gotten that right. We also only care about meeting the right-hand side when we have actual numbers. So if we have numbers that we can't exceed, okay? In this case, we wanted to be below 2,000 or equal to 2,000, so we're happy with that response. Second case, we wanted to be under 2,500, we're happy with that. Third case, we wanted to be under 3,000, we're happy with that, but it looks like we have extra. Okay, 2,568 means you have 332 left of crude oil. So you can tell your client you've actually got some extra crude oil to do something with, if there's something he can do with crude oil on its own. If it's sellable on its own, if he can make money from selling it, then 300 liters is a lot that he can still make money from. Okay, so that's going through each of your left-hand side items, checking whether you've met your right-hand side, and where you've got extra capacity, then point it out and say, oh, we've got extra of this thing. The client can do something with that extra. Sometimes you've got so much extra. If this was baking cakes and we've got tons of sugar left, then make some sweets or something. Make sense?
Yeah.
Okay, any questions? Hi Shane, yes, I haven't done the video on sensitivity analysis. Hopefully I'll get to that today and then I'll post it. But if you go through the Google Drive link with all the ALUX videos, there's videos on sensitivity analysis in there.
Thank you.
Okay. I'm just trying to pick the best question to do it for, and then I'll add it to one of our already existing questions.
Mrs. Wooter,
Yes.
if you have a question on one of the summative questions, can we ask you? Are you comfortable?
Yeah, as long as your question is not, is this correct? Okay. Because I can't tell you if it's correct or if it's wrong. That would be telling you the answer.
Okay.
So your question needs to be something like, oh, I don't know how to stipulate my percentages or how to deal with my percentages and my constraints. And what I will do is use previous examples to help you understand how we do that, and then ask you to try again. And I can keep trying to help you get in the right direction. I just can't give you the answer. So please do feel free to ask me.
Ms. Musa, Ms. Musa.
Yes, Annie?
Is there a probability or possibility where our summative could be extended to next week?
Oh, no. Why?
Like next week, Tuesday or Monday?
No. Why?
Because like, did it take so much time? It's like you actually have to concentrate and sit down and do it, and it takes time. And then counting how our other summatives are due, like EL is due on Sunday. Projects, I think projects is probably going to be due this week because
EL is a 2,000 word thesis.
Yeah, that takes time too.
You can do that in a day.
What? Not really.
It's writing. You can also do DD in a day. Okay, I'll tell you something about doing this summative. If you are hoping to make time to do it all in one go, you're shooting yourself in the foot. It's fine to sit down, do your 4 steps first up until the constraints, leave that and come back and do the next part. It actually keeps your mind more objective to do it in 2 parts. So if you do this and stop, the next time, if you come back and try to set this up, but it's not working, it forces you to go back to how you did this to begin with. And you might actually pick up mistakes. So I would advise, since you're only doing 2 questions, do it over 4 days. Do the first half one day, it takes about an hour. Next half, the next day, also takes about an hour. And then you're not trying to sit down for 4 hours in a row when you've also got EL due. Unfortunately, because we already lost so much time with this online learning, and GCU isn't really letting up on when we have to be done grading by, I can't really afford to move that summative.
Mutsa,
Yes, Amy?
I have 2 questions. Is it possible to increase the time that it's due rather than move it?
From midnight
Yeah.
to what time?
2 a.m.
Maybe on the day.
Okay.
I'm worried about you days before anticipating to need 4 more hours. That's not a good sign. Chances are, if you think days before that you need 4 more hours, you actually need an extra day. So I'd rather stick to the midnight deadline. I know some of you are significantly ahead in terms of time, and that means dinner time also, that your assignment is due. So I'll be cognizant of that. If you're a couple of hours late, I won't mark late.
Okay.
Okay.
And then my other question, for summative questions, would it be safe to ask you like if we're going the right direction or if we inputted correct things on solver? Would you be able to answer that?
I can answer if you're going in the right direction. In terms of how you're using Solver, I can't necessarily tell you if your screenshot looks correct. You should be able to double check that you've added your constraints incorrectly. This is also why I'm saying try not to do it in one sitting. It's easier to miss things when you do it all in one sitting. Whatever you missed the first time, you'll miss the second time, you'll miss when you're putting into Solver. So rather come back to it with a fresh mind, do the second bit, do your Solver. If something is not working, you can then trace back your steps. What I can do is, if you are sure that your Solver setup is correct and you want me to check and just make sure that maybe because you're using Solver instead of Open Solver, it's not working, then I can do that. I can tell you if the solution, if the problem is with Solver or if the problem is with your setup.
Could you say like you set it up wrong, try and check your constraints, and that could be the reason it's not working? Would you tell us that?
No, because you're
But
supposed
not
to be able to
specifically.
double check your work. Remember, this is a test. I can't, there's a limit to how much I can tell you to do. Being able to double check yourself is kind of goes without saying. So double check yourself, triple check yourself. When you know that each of your constraints is correct and it's not working, you can tell me. The best I can do is tell you that this is not Solver, this is you, in which case you're checking yourself for the 4th or 5th time.
Okay.
But in terms of directing you and saying you haven't done Solver correctly, that is part of the summative test. I need to know that you are able to do that without my leading you.
Okay. And then I know No, last time my solver had trouble putting it in, but then I did a screenshot of the thing. Would that be allowed for the summative if it doesn't work? And we checked and we think it's correct.
Yeah, that's fine. That's why I said just check with me so that I'm also sure that you put your constraints into solver and they're correct so that I can tell you that, okay, in this instance, the screenshot is fine. What I'm also doing is I keep trying to load my solver. Sometimes it works, sometimes it doesn't. I'm hoping and crossing fingers. I've sent lots of complaints that Google fixes it in the next couple of days. The minute it's working, I'm going to send you all a message on Hangouts to tell you to try and download your solver. I mean, your open solver.
Okay.
Okay. Any other questions?
Oh, one more. For the summative, I know solver is it would all the questions in the summative work well in solver if open solver doesn't work.
No, it's unlikely. Solver
Okay.
works. It's an old version. Even Open Solver is not great, guys. To be honest, those things are rated 2.5, 2.7 stars or something like that because they don't deal well with complex questions. Open Solver does a little bit better than Solver. Unfortunately, it's the best we could do without paying a lot of money for an actual accounting tool to do linear programming for us. So for our summative questions, OpenSolver for sure will be able to handle it. Solver might or might not.
Okay.
Yeah. Um, and remember, this is to just get you started so you're able to use a tool. In reality, when you leave, when you're actually working, you may use Solver again if they don't have anything else on site at work, but chances are they have other accounting tools that you'll have to learn on the job. But because you've got this foundation, it should be easier to know how to load everything. Any other questions?